Good morning, and welcome to some homework help. So, this is something we haven't really practiced in class, and maybe I should have given some time, maybe just at least one example in class earlier this week to help you out. Um, Even still, on the first day, I did tell you how to graph these things. And we did a bunch of those examples. Yeah, they were with parent functions and not these function transformations, but really, they're no different, okay? It's the same exact process as we were doing. It's just more math. It's just more arithmetic than it was before, okay? Um, Now, on the first day, the very first day of class, I said, I'm going to write this, I think, in yellow. So it was a little golden star here. Golden star. When you graph by hand, you need at least 3 points. Okay? Now, some of you have already submitted homework and you don't have those 3 points. I'm not going to take off for that now because I could have done a better job specifying this and really emphasizing it, even though I did say it. But your graph has to have at least 3 points before drawing the curve, okay? The only exceptions I'm going to give to this right now are rational and log, and that's because we actually use the asymptotes a little bit more, and maybe even exponential. We actually use the asymptotes to draw our curve more than we use points. But for every other parent function, linear, quadratic, absolute value, cubic, cube root, square root, I expect you to have at least 3 points. You must, okay? I'm going to ask for that on the exam. And it's going to be really important on every future test where you have to graph. So go ahead and get in the habit of finding at least 3 points. Okay, so this is to help you a little bit with homework 1.2, which deals with absolute value and quadratic functions. And in this video, I'm going to cover 4 examples. All right? 2 examples of absolute value and 2 examples of quadratic. Hopefully, these examples will be enough to help you on your homework. These are not ripped from the homework. These are their own examples, so you don't just get to really, copy the work. But hopefully me modeling this process should help you figure out what I expect you to do when graphing these graphs on your homework. Okay, so let's take a look at our first function here. I've got f of x equals 1/3 times absolute value x minus 2 plus 1. Okay, well, here's what I'm going to do. Maybe in green somewhere for you to see. I'm going to write a f of b times x minus c plus d. This is something you should know because we've talked about that in class, right? Those are my general function transformations. Now, what does that look like if my function is absolute value x? So if f of x equals the absolute value of x, then what does this general function notation look like for the absolute value function? It looks like this. Well, f of b times x minus c is your input, so I'm inputting b times x minus c into the function, which is absolute value. On the outside of those bars, on the outside of the function, I'm multiplying this by a, and I'm adding d. So that's what the general, that's like the more, formulaic form for absolute value with a, b, c, and d. And that's what it looks like. So take a look at that green form I just wrote and compare that to what's above. Okay, what is A? What is B? What is C? What is D? Well, I can write those, right? I can see it. A equals 1/3 C equals 2, and D equals 1. Hopefully, that's somewhat obvious now that I've written it in this way, okay? It's where A, B, C, and D are, right? There's no B value. There's nothing multiplying B times X. So 1/3 is the coefficient on the function, A, right? I'm adding 1 after everything. That's D, and it's X minus 2. That's C. So hopefully that's relatively straightforward. So what are these transformations? Okay. I'm going to shorthand here. It's fine for you to shorthand this on your homework, but on the test, I do want you to write it out fully, okay? But as long as I know what you mean, you're going to be fine. So A equals 1/3. That is a vertical compression. Vertical compression by a factor of... Now, this is where it gets a little tricky because the technical term would be 3. All right? This is vertical compression by a factor of 3 because you're compressing it by 3, right? It's 1 divided by 3. Everything's getting compressed. It's getting divided by 3. Now, if you write vertical compression by a factor of 1/3, I'm going to know what you mean, okay? And I won't take off. But this is technically how we should be writing it, okay? And it is what your answer choices on the exam are going to look like, so you may as well get used to it. The only reason I say maybe 1/3 would be okay is if A was actually 2/3, well, then it wouldn't be compressed by a factor of 3. It'd be compressed by a factor of 3/2. But I don't want you getting... We've already got enough to memorize, okay? And that distinction right now, I just don't care enough about it to make a big fuss, okay? If you recognize that as a vertical compression and you know that it's 3, that's that 1/3 that's doing it, we're good, okay? So don't sweat that. All right, now C equals 2. C is positive 2, so this is a shift right 2. And D equals 1 is a shift up 1. Nice. Let me make that a little bit clearer. That is up 1. That's a terrible one. Let's try that one more time. Haha, one more time. Haha. Okay. And I've got that. Now, when we're doing a sketch, meaning without graph paper, then you would just kind of sketch out where that vertex is and then do a little vertical compression. But notice what I starred in yellow. I'm asking you to graph this, not sketch it, graph it, which means I need at least 3 points, okay? So let's find those 3 points. The first one is easy because you can get it by just thinking about the vertex. The original vertex for a absolute value would start here at 0, 0, right? But it's shifted right 2 and up 1. So I'm going to go, let's say 2 to the right, 1, 2, up 1, right here. I know that that's going to be my vertex. So I found the vertex doing that. Now, how do I find more points? Well, you plug in things. And you just plug in things until you get points you like, all right? Now, this first one I picked is to be particularly tricky because that 1/3 does not play nicely. You're welcome to graph fractions so long as you show me what the point is. So if you label the point and it's a fraction, that's fine. But if it's unclear where the point is, that's not good, okay? So just make sure, if you're going to graph a fractional point, label it so I know exactly that you found that point. Otherwise, aim for pretty points. Yeah, aim for pretty points because that's going to be the nicest thing. And you say, how do you get pretty points? Well, I'm going to make a table here. x comma y. Now I know that if I plug in 2, I get 1, and that's because that's where the vertex is. And if we don't believe that, well, look at this. 1/3 times 2 minus 2 plus 1. Well, 2 minus 2 is 0. 1/3 times 0 plus 1 is 1. So that's my output. Do you see how I did that? Maybe I should have written this. F of 2. Notice I'm replacing this x value with 2. Okay, I plugged in 2, and I just chose to do that. Okay, and that gets me the vertex. Okay, let's erase that. Let's plug in another point. Now, you could plug in 3, right? So I'm going to write this. I'm not going to keep this. I just don't write this down. 1/3. I'm going to replace this x with a 3. So this is 3 minus 2 plus 1. Well, 3 minus 2 is 1. Absolute value 1 is 1. So this is 1/3 times 1 plus 1. Well, that's 1/3 plus 1, which is 4/3. And that's kind of icky. Now, if you want to graph the point 3 comma 4/3, that's fine. You could go 1, 2, 3, and then up 4/3 like that, and I would know that that's fine. But if you do that, I want to see that you label that point 3 comma 4/3. Okay, because you're being inaccurate, and we want to be accurate. Now, if you can graph on 2 whole number values, right? X and Y are whole numbers. You don't need to label that point because I can see it. I know what point you're talking about. But here's what I want to do. I want to find pretty points. Points that lie right on the graph, the sort of grid, okay, that I don't have to label because you can visually see them. Well, if you look at this as 1/3 times the absolute value of something plus 1, how do you make 1/3 times something a whole number? Well, there's a few choices, right? There's 1/3 times 3. There's 1/3 times 6. There's 1/3 times 9. Any of those are fine, right? Because 1/3 times 3 is 1. 1/3 times 6 is 2. 1/3 times 9 is 3. All of those are going to get you whole numbers. But then you just have to think, what value of x, when subtracted by 2, gets you those, right? I hope I'm not losing you here. But this is, well, we are in an advanced Algebra 2. We are in advanced Algebra 2. And I'm trying to help you learn how to think creatively about math and not just blindly copy procedures. So, here we go. I'm going to look at f of 5. And I say, why did he choose 5? Why choose 5? How do you know how to choose 5, Mr. Spake? Well, just watch what happens. F of 5 is 1/3 times 5 minus 2 plus 1. Right? Well, what's the absolute value of 5 minus 2? That's 1/3 times absolute value 3 plus 1. That's 1/3 times 3. That's 1. And 1 plus 1 is 2. So when I plug in 5, my input is 5, I get out 2. 5, comma 2. You see how that's a nice point, right? That's way prettier than 3 comma 4/3. That's nice. I can grid that easy. And I knew to choose 5 because I'm thinking forward. I'm thinking 1/3 times 3 is going to get me a whole number. So what number do I put in for x that would get me that 3 there? That's what my thinking was. So now I'm going to come over here. I'm going to do 1, 2, 3, 4, 5, comma 2. Nice. Okay. And now here's something kind of cool. With an absolute value function, we're actually done. And we can get the next point for free because the axis of symmetry is here. this is the axis of symmetry, which, by the way, lies at x equals 2, okay? And whatever is on that right side of that line, the image on the right side of that line, is mirrored over. So, looking at that point right there, what is the mirror image of that point across that axis of symmetry? Well, I went over 1, 2, 3, up 2. So, oh, also, did I plot that point wrong? Oh, I did. I'm sorry. Boop. I said it was 5, 2, not 5, 3. Sorry. There it is. That's the point. There we go. There we go. But still, same concept. Map that point, mirror it on the other side. Go over 1, 2, 3, and that point is here. I'm using symmetry to help me get the next point. And we're going to be practicing this, I think, in Unit 3 or Unit 4 with parabolas. So it's a good thing to just get started now. And I'm going to draw my line. Let's draw a little bit better line. Like so. Make it a nice straight line. And then try and connect this one with a straight line too. And there we go. Okay? And that's my absolute value function. Nice. So notice what I did there was I used symmetry. Incidentally, that point that's right here, that point is negative 1, 2. And look at your function, right? F of x equals 1/3, right? I'm looking at this. So if I plug in negative 1, do this in red, 1/3, this absolute value, negative 1 minus 2 plus 1. Well, negative 1 minus 2 is negative 3. So this is 1/3 times absolute value, negative 3 plus 1. Absolute value of negative 3 is 3. So this is 1/3 times 3 plus 1. That's 1 plus 1. That's 2. So by plugging in negative 1, I get that same y value, negative 2. Okay? All right. Good stuff. And I'll, you know what, just for negative 1, 2. And that's how I used symmetry. Symmetry is very useful in graphing both quadratics and absolute value. Now, if you didn't know how to use symmetry, just keep plugging in numbers, okay? But considering that you need this graph, like, I mean, you need something on the left and the right side of that vertex if you want to graph this accurately. Just use symmetry. It's much easier than having to fiddle around with other stuff. Okay, let's see domain and range here. Domain, notice, just look, now that you've graphed it, you can look at the picture, right? Your domain should be, everybody says, all real numbers. So, domain is negative infinity to positive infinity. Another way to write this, x is between negative infinity and positive infinity with less than signs. Yeah? And then you got your range. Notice my range, I shifted this up 1, right? I vertically compressed it, but the thing that affects the range is an up 1. And it starts right here vertically at 1 and goes up. So my range is bracket 1 to infinity. And I would say that this is y is greater than or equal to 1. And that's it, actually. I don't have to say less than infinity. I can just write it like that. Y is greater than or equal to 1. You might, if it was an answer choice, you might see it reversed like this. Y, yikes. That's hideous, disgusting, oh my gosh. I can't live with myself. Okay, there we go. Y is greater than or equal to 1 is that point. Yeah, or is that range. Nice. And finally, my vertex, well, I mean, you can see it. We already kind of got it, didn't we? My vertex is 2, 1. And there you go. There's all the pieces. So that's what I'm expecting you to do for your homework. All right? That's the goal. I know that took some time to explain, but the more practice you do, this is going to get really fast. All right? You're going to get really, really good at this over the year. Even if you're starting out rocky, even if you're saying, Mr. Spake, I feel like I'm drowning, I feel like I don't know anything, I think you're picking up more than you think, all right? So don't knock yourself too hard. You're all really smart, hardworking people. Just keep working at this. It's going to come, all right? It's going to come. Now, I could do this next one, but it's really just going to be me repeating all the same stuff. So I'm going to go ahead and go over to quadratic. I'm going to go back, okay? I'll go back to that one for later during the video, but for now, I'm just going to work on quadratic. Try this one out. That way you can see it. And then if you really, really want to stick around for the next two, I'll work those as well. Okay, but they're not really anything special. Okay. Next one, quadratic. And I'm gonna write this in yellow again. When graphing, need at least 3 points. I better see those 3 points, all right? Got to see them. I'm going to be picky about that, all right? I know it's annoying, but my teachers were picky with me, and for good reason, all right? It was for good reason. It helped me a lot in understanding graphing, because when I first started graphing, I felt like I had no idea what I was doing. I had no idea how to read domain and range. It made no sense to me. But by doing this, by practicing this, by graphing at least 3 points and really carefully plotting these functions, it helped me a lot. So trying to do the same for you. Okay, function f of x equals negative, parentheses, 2x plus 4 squared minus 1. Now I'm going to do that same thing I did earlier in green. Okay, if a f of b x minus c plus d, what does this look like if f of x equals x squared? Well, it's really similar to absolute value, but the input is the thing getting squared instead of an absolute value. So my input is b times x minus c squared, and then putting in a, and then there's my d. Okay, that's what that looks like. So compare that to up here. And this one's going to be a little bit harder to see. So I think I'll do this in red. That 2 right there is a b value. But it's supposed to look like b times x minus c, not b times x and then minus c. It's like b distributes to x and distributes to c, which is not how this form is written. Spoiler alert, spoiler alert. I'm going to whisper this. I don't think this is on the test. So, if you're really worried about factoring this, don't. Okay? And that's a little helpful hint to those of you who have actually decided to watch this video. Anyway. So let me rewrite this as negative, parenthesis, 2, and I factor that as x plus 2 squared minus 1. Now it looks like the form, right? Now it looks like that thing I wrote down there in green right here, yeah? So, reverse that. Let's identify ABC. I'll do this in blue. Blue. A. What is A? A equals negative 1. Yeah, that's that negative sign out in front. By default, it's 1. Okay? I mean, if there's no number there, if it's multiplying, it's 1. If it's adding, it's 0. Yeah? Next is your B value, which we identified as 2. then your C value, not positive 2, but actually negative 2, and that's because of that whole thing we talked about in class, the whole what are these called? Apostrophes? Quotes. My gosh. Good thing I'm not teaching English, right? X plus 4 in quotes, right? Looks like that. That means shift left. So C is actually negative 2. Okay? And if you don't know what I mean by that, go rewatch the lesson 1.2 video. And then D equals negative 1. So what does this all mean? This means a vertical reflection because A is negative. B equals 2 means, what is that, horizontal compression? Yeah. Horizontal compression by a factor of 2. I hate writing this. Oh, gosh. Blah, 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 blah. By a factor of 2. Yeah, who cares? Okay. And then C equals negative 2 is a shift right. Oh, nuh-uh. No. Left, silly. Shift left 2. And D equals negative 1 is down 1. Yeah? Nice. Woo! Herp hippie, hooray! Okay. We'll figure out domain and range in a second. Let's graph this guy. Let's graph this baddie. I would always start with a vertex if the function has a vertex. Okay? If it... I guess that we could have more in... Okay. We're going to talk about this more in each unit as to what point you need to graph. But for now, just think whatever the defining point is for a graph. So like absolute value and quadratic, that is a vertex. For a cubic, that's the point of inflection. For a square root, that is a endpoint. Okay, so it's whatever that starting point is, that's usually a 0, 0 for our parent functions. That's what I'm going to think about in terms of shifting. So this shifts left 2, down 1, tells me uno, dos, and uno, right? So left 2, down 1 is right there. And if I'm drawing a table, x, y, you know what? This is going to point downward, so I'm actually going to do it up here in red, no less. X comma y up here. Plugging in negative 2 yields negative 1. And you can test that, okay? You can test that with this function. If you do negative 2 times negative 2 plus 2 squared minus 1, well, negative 2 plus 2 is 0, and 0 times 2 is 0, so 0 squared is nothing, and negative nothing is nothing, so it's 1, right? It's negative 1. Plugging in negative 2 just cancels all that. I mean, it all just goes to 0, and then the minus 1 is all that remains. Okay, but I didn't actually have to do that. All right, but I do need another point. I do want another point. And I would just test one point to the left or right of the vertex. You don't need to test any others. I'll test 1 point to the right of the vertex. So it's at negative 2. Let's test out negative 1. So it'll make my life easier if I plug it in this. Okay? I'm going to plug it into there. So this is negative. By the way, I'm plugging in negative 1. This is negative 2 times negative 1 plus 4 squared minus 1. Okay, 2 times negative 1 is negative 2. Negative 2 plus 4 is positive 2. So this is negative 2 squared minus 1. 2 squared is 4. And that's negative 4 minus 1, which equals negative 5. So plugging in negative 1 gets me negative 5. So I'm going to go over 1 and down 1, 2, 3, 4, 5. That's right here. And like I said, you can use that symmetry, right? Since you know that that first point we plotted is on the axis of symmetry. This is axis of symmetry, x equals -2. Then just flip that point over. It's right here, right? That's the other point. And so that is -3, comma, -5. And now I just draw my parabola. So I'm going to try this. Ooh, let's be careful. Woo! I think I wanted it to be a little bit fatter. It's hard. I do this better on pencil and paper. You know, I actually Googled, there's this type of iPad like cover, well, not like a screen protector that's like paper. It's like paper-like. And I saw a video. It works super well with the Apple Pencil, which is what I have. But it it apparently ruins your Apple Pencil if you use it too much. So, sad. I'll just have to go with the digital screen. Okay. And there's my graph, right? And I got those points for free. You only need those 3. Now, you're welcome to find more, but those 3 are good enough. Okay? And now, from here, I should be able to figure out the rest. No problem. Domain, you're looking at the graph. It reads all the way left, all the way right. It's defined for all real numbers. So the domain is -infinity to +infinity. Range, however, has been shifted down and flipped. So notice it's pointing down, which means it goes down to -infinity. And it rises up to a maximum of -1. So I'm actually going to put a -1 here. Let me zoom in, because I know on a YouTube video it might be harder to see than my physical iPad here. So it goes from -infinity to -1. Bracket, since it hits that point. What would this look like in inequality notation? Well, x is less than infinity, more than -infinity. And then the range, this is all y values smaller than -1 or equal to. Okay? Everything below -1, so y is less than or equal to -1. And then my vertex I already found. It's at, what did that say? It said -2, -1. So my vertex is at -2, -1. Now it's getting a little sloppy to read with all that business, but whatever. It's good. It's all right. Okay? There you go. That's the expectation. And I hope that this helps out. Okay? That's pretty much it in terms of guidance and help. I am going to work the next 2 examples if you'd like to just see even more. But I'm really just going to work them. I'm not going to explain nearly as in-depth as I have here. We've covered the basics. You need at least 3 points. And with quadratics and absolute values, since they have an axis of symmetry, you can use that symmetry if you know the vertex and another point, right? Because you just reflect that other point across the axis of symmetry, you get your third for free. So yeah. Okay. Let's look at this one. So I'm just going to jump straight into this one. Compare, where is it? Compare this to this, right? What is A, what is B, what is C, what is D? We should say that A equals -1, C equals -3, and D equals -5. So what are these transformations? This is a vertical reflection. This is a shift left 3 down 5. All right. Domain. Oh, right. Well, let's graph it, actually. Let's graph it first. Can you figure out where the vertex is? Well, vertex used to be at 0, 0. It used to be here. It's no longer there. It is somewhere else. It is shifted left 3. 1, 2, 3. Why is my graph so wonky? That's hideous. Oh, I don't like that. Do you see this? That's terrible. What a terrible graph. It's not aligned. Let's redraw this. Icky. Nice. Oh, that's so much better. Yeah. 1, 2, 3. Is everybody having a good Saturday? I hope everybody's having a good Saturday. I hope everything's going well. I know we're starting strong in here. Starting strong. And there's my point. Left 3, down 5. Of course, you may not be watching this video on Saturday. You may be watching this video the night before the test. In which case, good luck tomorrow, I suppose. All right. That's that point. -3, -5. Right? If I'm making a table, X and Y, I want to change the thickness of the marker because when I use that thickness, it just gets too messy. X, Y, it's -3, -5. That's my vertex. So I'm going to erase that. Okay? Let's find another point. I like plugging in 1 to the right because, well, I don't really need to do any trickery here like I did with that very first example where I was like, ooh, well, what's a good value to pick? I pick 5, right? 1, let's see, let's do -2 because this would be the next x value, right? So -2 plus 3 minus 5. Well, -2 plus 3 is 1. Absolute value 1 is 1. So this is -1 minus 5. That's -6. So it looks like it just goes down 1. Like that. And then you just utilize that axis of symmetry again. And you get that point. And that's all you really need. You're welcome to plug in more, right? But the points that you will get, if you plug in -2, you get -6. If you plug in -1, you get -6. Sorry. Not negative. -4, sorry. Yeah. Whoops. Yeah. Okay. Yeah. And those are your 3 points. You're welcome to plug in more. I mean, you can plug in like, I don't know, -5. Negative absolute value, -5 plus 3. -5 plus 3 is -2. Absolute value -2 is 2. So this is -2 plus minus 5 equals -7. Woo! Right? And so I would get this point right here. And then reflect it right here. Okay? Yeah, so yeah, that's what my graph looks like. Let me draw a nice straight line. Nice straight line. Okay, that one's not straight. That's terrible. Whoa! Whoa! Okay, that was unnecessary. Let's try that again. All right. Done. Okay? All right, what's my domain? Domain, all real numbers. If that's not clicking yet, well, just keep fermenting on it. Just keep thinking. Just keep that brain brewing. All right. It goes all the way left, all the way right. It's all real numbers. The range, it points downwards towards -infinity, and it goes up to, what is that point? -5. So it goes up to -5. We'll put a bracket. Again, in interval notation, this is x is between negative and positive infinity, and y is everything less than or equal to -5. And then my vertex is so gracefully at -3, -5. Beautiful. Done with that one. Yeah? Cool. All right, one more. Okay. Let's do this function. Oh, yikes. Oh, that one's gross. I came up with this myself. That's not very nice of me. It's not very nice of me, actually. Now, the cool thing is I could actually play around with this to make it a simpler function. I'm going to show you this real quick. If I factor out 3, then I can square that 3 so that it's 1/3 times 3 squared times x minus 1 squared. And 1/3 times 3 squared, well, 3 squared is 9. 1/3 times 9 is 3. So actually, that's a simplified version of this function. I do not expect you to know that, okay? That might be something we cover later in class. But I just wanted to show you that, and if that makes sense, yippee hooray. But you're fine. You don't need to do that, okay? What you do need to do is notice that this bad boy and this bad boy need to be interpreted, as the same, and that 3, right? This b value and that 3, you gotta factor it out, okay? So let's do that. I'm gonna factor this out as 1/3 times 3 times x minus 1 squared. Okay, so what are my numbers? Blue. A equals 1/3, B equals 3, and C equals 1. So this is actually horizontally and vertically stretch compressed kind of stuff, right? It's vertically compressed by a factor of 3. But it is also horizontally compressed by a factor of 3. Isn't that funny? And then it's shifted right 1. By the way, there's nothing this hard on the test, okay? Just so you know, just in case you're freaking out. I think the test is a lot easier than your homework. All right, let's plot some points. Let's get those guys in here. Vertex used to be at 0, 0. Now it's shifted right 1. So the vertex is here, right? Which is at 1, 0. Then we can find some points. So let's plug in some nonsense. I like the point 2. I'm going to say, what's f of 2? F of 2 is 1/3 times 3 times 2 minus 3 squared. 3 times 2 is 6. 6 minus 3 is 3. So this is 1/3 times 3 squared. 3 squared is 9. 9 times 1/3 is 3. So when I plug in 2, right, if I have x comma y, my vertex is 1, 0, but if I plug in x equals 2, my output is y equals 3. So 1, 2, I go 1, 2, 3, like that. Yeah. And again, you can use that axis of symmetry and then just flip that point over, because you know that 0, 3 is going to exist. And you can test that because 3 times 0 is 0, and then 0 minus 3 is -3, and -3 squared is 9, and 9 times 1/3 is 3. So it all comes back to 3. And there you go. You don't need any more points. I told you only need 3. So draw that nice parabola. Try to make it curved here. Try to make that U shape. It can be hard to make that U shape when it's really skinny, so I understand. Okay, I understand. I'm not going to be ultra picky about that. But if it's not sharply curved there, then you need to make sure that's a curve. Okay, domain. Domain is all real numbers. Range starts at 0, goes up to infinity. And we can say this is y is greater than or equal to 0. And I'm just getting that by looking at the graph. Again, starts at 0, goes up to infinity. So that's my range. And there you have it. All right. I hope that these 4 examples are helpful in figuring out your homework. Yeah. There it is. Okay, I'm going to go finish the rest of my apple fritter now. And I think just kick back and try to enjoy my weekend, I guess, if I can, if that's even possible. I guess I got to get started on Unit 2 materials, huh? Because that test is coming. All right. I'll see you guys later. I hope this was helpful. And I'll also try to upload a video either today or tomorrow for homework 1.3 to help with that too. Take care.